Hey guys, welcome back. I'm Sudhansara from Electro and today I'd be explaining how an electric motor works. So to understand this topic, first we have to talk a little bit about some basic concepts. So there is this great thing about an electron that when it's kept static, it has no magnetic fields, but it has an electric field. But when it's having a velocity, it produces magnetic fields. Here you can see as we all know that when there are two magnets close to each other, they will interact. And why is that? Because both of them are in the region of the magnetic fields, so they apply some force to each other, right? So we know that a north pole and north pole means the like poles of a magnet will repel, and then like poles will attract. Now, what is a moving electron? By definition, electricity is the flow of electrons, that is moving electrons. So that means that if we have a wire, so that wire, if it carries electricity, will have some magnetic fields too. And we also know that when magnets are close to each other and they are both in the region of the magnetic fields, they both will apply force to each other. So here, when we have a current carrying conductor and we also have a magnet, both of them have a magnetic field, right? If they are close enough to each other that they both are in the region of their each other's magnetic field, they both will apply force to each other. So this is the principle on which the electric motor works. So to find the force, where the force will be applied when we have a current carrying conductor and a magnet, we have a rule called the Fleming's left hand rule, which will help us find the force and where that force, in which direction that force will be applied. So here you have the diagram of an electric motor, the internals of an electric motor. So here you can see the north pole and the south pole of a horseshoe magnet, and there's this coil which has some current applied to it. Now we knew that when two magnetic fields are close to each other, they apply force to each other, right? So here we have a coil which is carrying some electricity, and we also have a magnet, so both of them will both of their fields will interact, right? Now by using that Fleming's left hand rule, we can find out the direction of force where this force will be applied. So here for this part of the coil, from here to here, the direction of current is towards you, and the direction of the magnetic field is from your left to your right, correct? So here's your magnetic field, so it's here, and current is pointing towards you, so your force will be applied upwards. So you see the coil will move upwards, this part of the coil, and for this part of the coil, current is moving away from you, and the direction of the magnetic field is from your left to your right. So the magnetic field is moving in this direction, but the force is not towards you this time, it's in the opposite direction. So you can see the force, the electric current is not towards you, it's away from you. So you see the force will be applied downwards. The thumb indicates the direction of force. So for this part of the coil, from here to here, it will move downwards. So as a whole, this whole coil will move in a clockwise direction, right? Now if it's moving in a clockwise direction, here what happens is that this whole unit from here to here, it's a completely different unit from this part of the circuit. So as electric current passes through it, and at the moment when this force is applied to both parts of the coil, when the coil moves, it breaks the circuit. It's no more connected to the battery here. So due to inertia, it will keep moving, and as well as the axle connected to it here, the line here represents the axle, it will also keep moving with it. And as it completes a 180-degree cycle, it will reach to the points where those terminals were, and current will again flow through it. So as current flows again, the cycle continues, and then the coil keeps moving. So this is how an electric motor works, and I hope you understood how an electric DC motor works. And now if you did, don't forget to smash that like button and do subscribe to my channel. So stay tuned, and thank you for watching the video. Bye bye.